Hi there, and thanks for watching. This is Lab 2 of Physics 2212, Magnetic Field of Permanent Dipole Magnets. The purpose of this lab is to measure the distance dependence of the magnetic field. This is done using a bar magnet and using the magnetic sensor on a smartphone. The magnetic field is then simulated in Python, and we're going to compare the experimental measurements to the distance dependence that's predicted by the equations in Python. The most important concept for this lab is magnetic fields, specifically the magnetic field due to a dipole, which is given by the equation here. So this is a brief preview of what we found. We calculated the magnetic moment of the magnetic dipole to be 0.83. Bnet is the magnitude of the magnetic field at a 45-degree angle from the magnetic dipole. Experimentally, that was computed to be 2.42 e negative 5. Computationally, that was computed to be 8.72 e negative 6. And worth noting, we observed a linear relationship between the log of the observation axis and the log of the magnitude of the magnetic field along the axis of the magnetic dipole. So this is an experimental model. We're going to use a magnet, which is a magnetic dipole, and that produces a magnetic field as shown in the image. And then we will be using a phone to detect the magnitude of the magnetic field at various locations relative to the magnet. So the magnetic field of the magnetic dipole has a parallel and perpendicular axes, as shown in the equations here, and those will be used in order to calculate the value for the magnetic moment of the magnet. So in the initial setup, the phone is aligned with Earth's magnetic field. This is important because we want to make sure that the measurements are accurate and aren't skewed by the magnetic field of the Earth. The phone also needs to be placed on a flat surface. So in this experiment, we're first going to measure the distance and magnitude of the magnetic field at various locations along the parallel axis, and then we're going to measure the net magnetic force at a 45-degree angle to the parallel axis. So here are the results of the experiment. Again, we observed a linear relationship between the log of the distance of the magnet and the magnetic field that was observed. The net force at a 45-degree angle from the parallel axis was observed to be 2.42 e negative 5 teslas. So using the formula for the magnetic field parallel to the magnetic dipole axis, we're able to calculate mu to be 0.83. This is the setup for the code. Note that the value for the magnetic moment is what we obtained from the experiment. So this is a function that's used to calculate the magnetic field as a function of a magnetic dipole moment. This is the output of the code. The orange arrows represent the magnetic field on axis of the magnetic dipole. The blue arrows represent the magnetic field parallel to the magnetic dipole, and the purple arrow represents the magnetic field at a 45-degree angle to the magnetic dipole. So in comparison, the magnitude of the magnetic field at a 45-degree angle was calculated to be 2.41 e negative 5 in the experiment and 8.72 e negative 6 in the computational model. So the experiment was about 3 times higher, which isn't that much, but it isn't perfect either. So that was likely due to potential sources of error, which I'll discuss next. So a couple potential sources of error. First of all, the magnetic phone sensor on my phone probably isn't very good quality. Second of all, due to rain, the experiment had to be conducted inside, so there could have been other sources of magnetic fields that interfered. So what if the phone wasn't aligned with Earth's magnetic field? In that case, we would have had a constant add-on to all of the measurements that we took for the magnitude of the magnetic field in the x direction. So we would have had to subtract that constant in order to make the measurements more accurate. So what if instead we use two magnets stacked together? Well, that have the effect of doubling the moment of the magnetic dipole. And since the magnitude of the magnetic field is proportional to the magnetic moment, that would have the effect of doubling the magnitude of the magnetic field that was observed. So, in conclusion, we observed a linear relationship between the log distance of the magnet and the log magnitude of the magnetic field. We used a computational model to calculate the magnetic field and observed a similar result to the experimental result. Again, this has been Lab 2. Thanks for watching and have a great rest of your day.